Okay, ready? Hello everyone, welcome to the speech. Because I think it's very interesting and very specific. I'm not an expert of this and leave the word to Marc-André. If you have any questions, just take notes and we will go through the Q&A session after the speech. Thank you.
Thank you. Well, I haven't actually shown anything yet, so I think the clapping is for afterwards. If you have questions during the talk, just feel free to ask them, yeah, so that we can have more context available when the question comes in. So I'm going to talk about a project that we did in the last couple of years internally in Eugenics. It's a Python runtime environment, a very compact one that's easy to ship to customers and clients and put into installers. So first of all, a little introduction. I'm Marc-André Lembuirg. I'm the CEO of Eugenics.com. I'm also a Python core developer, and I'm a Python Software Foundation board member. At Eugenics, we're running basically custom solutions for customers, all written in Python. We're doing consulting work for Python. We also have a separate line of products that we make available commercially and open source. And this project that I'm going to talk about here is an open source project, so you can download it and install it and use it in whatever way you want. Right, so I'm going to have a very short agenda here. First I'm going to do a short introduction of the project, then I'm going to show some use cases. There are probably a lot more use cases than the ones that I'm going to mention. Then I'm going to go into the technical details and have a discussion afterwards about other projects doing similar things. And let's start with the introduction of the project. So what we were looking for at Eugenics was a very simple way to install Python on a customer Unix system. And if you've done that before, you probably know that relying on the system installation that comes with Unix is often a very tedious thing, because the system installations of Python, they tend to be customized in various ways by the distributions. And they tend to have, well, sometimes they have problems with dealing with your stuff. They install things in different paths and then in non-standard locations. So ideally, you just want to avoid all these hassles, and nowadays disk space is cheap and bandwidth is available too, so it would be better to just ship your whole Python distribution together with your product. So what we're looking for is something that has a small footprint, a small download. Disk space is cheap, but of course customers don't want to wait, so you have to make things fast for them. You don't want them to download a 100 megabyte Python installation just to be able to run your product. We also wanted it to be easy to add to installers, because we ship the product with installers, and it should support all the standard things that you have in Python. So it should load .py files, it should load bytecode files, and very important, it should load C extension modules. So when we started this project, we started that 4 years ago, we remembered an old project that we ran many years ago, from 1999 to 2006, which was called MX CGI Python. That was a project aimed at installing Python on FTP space that you could buy at the time on hosting at hosting services. Around 1999, when you rented some FTP space, what you normally got was you could run CGI scripts at that time, but only Perl or Bash. That was about it. And of course, we wanted to run Python on those FTP accounts. So we came up with the solution to create a very small Python distribution that you could actually send up to the FTP space, and then you just have a shell script installing it on the FTP space. And so thereby you get the CGI capability for Python on your FTP space. Nowadays it's not a problem anymore, because the hosters usually provide Python support anyway. But at that time it was very tricky to get that up and running. So in Python 1.0, we support a few Python versions. We don't support 3.x yet. We haven't looked into that yet. It might work. It may not work. There have been quite a few changes in the setup, so we're not sure whether we could make it work. What we do have is we have support for 2.5, 2.6, and 2.7. And most of the time, we'd probably just use 2.7 anyway. We have binaries available for the product that you can download and readily install for Linux, FreeBSD, and Mac OS X. But if you download the source code and you compile it yourself, it should work on other Unix-based platforms as well. We currently don't have Windows support, but we're going to look into that and probably make that happen as well. Okay, use cases. Well, obviously, the use case for us, the main use case was distribution of scripts and applications to customers. We have this MX-ODBC Connect server product. That's a server application that people install on their Unix servers. But we also wanted something like a virtual env replacement. Because it's the Pyrun is very, very small, you can just copy the file to various different directories and then have multiple installations on your system without touching the system installation, which comes in very handy if you want to test stuff or you want to run different Python versions than what you have installed on your system. It's also very useful for testing and scripting. So basically, if you do throwaway stuff or you just want to temporarily install Pyrun in some directory and then run your unit tests on them. It's good for having application private installations. For example, if you install Track on your server, you might want to have a dedicated Python installation just for Track on that server instead of using the system one. Because of the size, it's also interesting for embedded devices, but we don't have any experience with that. I just put that on the slide there. And there are probably many use cases that we've not listed here, so it's basically up for experimentation there. What makes it ideal for applications and scripts? Well, for scripts, it's very important to have the startup time of Python be very fast. And that is something that is, well, for 3.x, for example, it's a bit of a problem at the moment because the startup time has gotten a lot worse than for 2.x. If you look at the startup time for 2.7, for example, you have user time is 45 milliseconds. With Pyrun, it's just 26 milliseconds, and that's due to the way that Pyrun works. I'm going to explain that later on. Plus, of course, it uses only a fraction of regular Python installation. So if you have a standard source code-based Python installation on your system, that'll take about 100 megabytes. May vary a bit depending on 32-bit or 64-bit and the number of extensions that the system finds on your system. But that's about the order of magnitude. And Pyrun itself is just a 12 megabyte file. So it's very small. Plus, you can compress it further to just 4 megabytes, or even if you use UPX, which you might know it's an XC compressor, it just uses 3.5 megabytes, so that's very, very tiny. Plus, of course, you get the same compression ratios if you put it into zip or tar.gz and then ship it as download. So that makes things interesting. Now, the next use case I want to look at is the virtual env replacement. Because it's just a single file, you basically just have to copy a single file to a directory and you're done. If you want some more flexibility, say you want to also install some extra extensions using setup tools or pip or other such tools, then you have to set up a directory structure, but that's about it. And this could be made even easier using a shell script that just does all the copying and creating of directories for you. Unlike virtual env, you don't need any activation script. So you can basically just go ahead and just run your Python application there. Then, as I mentioned before, it's independent of the system, the Python system installation. It doesn't need a Python system installation, which makes it interesting for example, for banks that have a few hundred servers and they don't want to install Python on each of their servers just to get a script running. Or banks, I mean, just any company that's has a few hundred servers there. You basically work around all the quirks that you might have with the system installation. You don't have any symlinks to manage, like with virtual env, and it's fully relocatable, which virtual env installations are not, because they put the path into the various scripts that virtual env creates. And then, of course, it's small enough to just have multiple copies. If you want to install Pyrun with pip and setup tools installed, it's just 13 megabytes. And you can run pure Python code, you can run precompiled Python code, you can run precompiled shared extensions for Python. You can use just standard Python extensions that were compiled for, say, Python 2.7 and run them with Pyrun. There's no difference there. What you cannot do is you cannot compile extension modules using that setup. If you want to do that, you have to invest a bit more disk space. It's 36 megabytes because you also need the include files installed with Pyrun. And then you can use Pyrun to compile your extensions even on the fly. You can use easy install or pip to install extensions that come with C extensions. And it just works. And after you've compiled and installed things, you can remove those include files again, so you're back to an even smaller number. So, technical details. How does Pyrun actually work? I mean, what makes it work? We're using a tool that's very, very old. It sits in the tools directory of a Python source installation, and it's called freeze. And what freeze does is it takes the original aim was to take your application, go through the application, find all the module dependencies, and then put all those modules into a single file. And it does that by compiling the .py modules that it finds into bytecode, and then creating C files that just contain the bytecode. And then it compiles all these C files into modules, and well, C modules in that case, and adds them to the binary. So what you have is you have an executable with the standard Python interpreter, and then added to that or linked to that, you have all these static data files having the bytecode of Python or your Python application. So that's basically how it works, and it works reasonably well. It's very efficient to use. The startup time decreases because you don't have any I/O when Python starts up, because it doesn't have to find, for example, the os.py file in order to figure out where the standard lib installation is. It just loads things directly from the executable, and because nowadays the operating systems usually map the file directly into memory, that's a very efficient process. Plus, you can share the space that's being used in memory, because if you have multiple Pyruns running at the same time, of course, all the static data will be mapped into the processes already, and the OS will be clever enough to share that available memory between processes, so it doesn't take up multiple copies of the application that you have there. And now what we did is we basically used that approach, except that we didn't have freeze run on our application. We just let freeze run on the whole standard lib library. Plus, we had to add a few more things to the module setup file in order to get extensions that are normally compiled as shared extensions in Python, to get them compiled as static extensions, so that they get integrated into the Pyrun executable. And then we have a few generated Python scripts that we need in order to turn this whole thing, which is normally just an application that doesn't take any command line arguments, and we wanted to make it look very much like standard Python. So we had to emulate command line switches, for example. We had to play a few tricks to get distutils and setup tools working, because they expect the configuration data in what you normally install as development files. So when you install development files on a system, what happens is that you get the make file that was used by the installation process, the Python installation process. You get that copied into your include directory. Plus, you also get the configuration data from that installation run, added to your include directory, and then distutils takes that, parses it, and uses it for actually installing your C extensions. Now, what we did is we basically took those generated files and converted them into Python modules, and then we just add those Python modules to Pyrun, and then we monkey patch distutils and setup tools in order to pick up that configuration data instead of going out to the file system and looking for make files or config files. So that was a bit tricky to get that working, but so far I haven't found any issues with that. Now what we also did is we made the whole thing relocatable. So we're not using the standard Python approach for installing the binary. What we do is we take the path of the binary, and then relative to that path of the binary, we set up a search path. So what you have is if you install, say, Pyrun in the bin directory, then it'll go back to the root of the bin directory, and then it'll search for lib python.2.7 and include Python 2.7 to find extra things that are installed. And that way you can just move your Pyrun around in your system. You don't have to reconfigure anything, it'll just work. Using that directory structure, we set up a search path also in a slightly different way than what Python normally does. So first you have, well, this is standard stuff. First you put in the directory of your script that you're running there. Then you add the Python path directories. And then you add these relative directories to the syspath in case they exist. If they don't exist, those don't get added, so you don't get any extra I/O checks there. This is just done once during startup. And once you have that set up, you can install extra modules. You have your side packages there. All your extra modules that you install in Pyrun, they get added to the standard side packages directory there. And it works pretty well. I think I already mentioned everything we did here. So this is basically how we made the Pyrun compatible to distutils. We had to play these tricks with the configuration. Originally, we wanted to use a different Python directory layout in order to make it completely independent of a system installation. So we even wanted to change the lib Python 2.7 into something else, but it turned out to make things too incompatible to extensions because they often have these directory names hard-coded in Python modules, so we didn't want to change that. So basically we just went back to the standard Python directory layout. We had to add a few extra command line options that we did not originally support, like the -C one, which is required for pip. But that was about it. I mean, with these changes, things just work. At least the things that we normally do, they work. If you find things that don't work, just mention them to us, and then of course we'll have a look and add them. We have not yet checked ZC build-out, which is basically a setup tools setup tools based configuration system, but it might just work out of the box. This would be interesting for, say, if you have clone installations or open installations. So what's missing? Of course, this is just the runtime, so it doesn't need certain things. For example, readline is not included in the Pyrun executable. Or in our applications, we don't need the parser, we don't need tkinter. We don't use multiprocessing, but the reason why we left out multiprocessing was that it's rather difficult to get that compiled as static as static component into and linked into the executable. We don't have the DBM modules in there. We don't have crypt in there because of export stuff. The DBM modules, well, we don't use them. It's usually better to use SQLite nowadays. And of course we removed all the test packages and sub-packages because we don't need those in there. But you can add all these things extra. So for example, if you want readline, if you want to use it interactively, you might want to have readline. Readline is compiled in the process of creating the Pyrun binary, and you can just then copy the .so file to that lib directory and it'll just work. Okay, so I mentioned what was not included, so what doesn't work. We found that because we tried to, of course, run this Python test suite, we found that using this regular test.py that's normally used for controlling the test suite, we found that some of the test modules don't work. And it's a bit strange because if you run those modules that don't work with regular test, if you run those standalone, they do work. We have to figure out what's going on there. And of course, due to the way that Pyrun is built, there are certain things that simply don't work by nature, because some standard library modules they want to access files within the packages and then load things from there. For example, idlelib is one of those. Or if you have bdist wininst, bdist wininst builds Windows installers, and it uses a stub that it loads from the package. And of course, many test packages don't work, but they are not included anyway. So, yeah. If you use separately installed test packages, they do work, of course. So we used an open source license on this. The standard Eugenics public license, like we put on all our open source things, and then of course you have the standard Python license because we pull in the complete Python installation. Discussion. Like Freeze, there are some other tools available that you could use to do similar things. For example, Py2exe, that's something that we use a lot on Windows. Then you have Py2app and the bdist M package add-on for distutils. That is a nice thing for Mac OS X. You have CXFreeze, which works on Unix and Windows. You have PyInstaller, and you have bbfreeze, which works on all three. But they usually have a different target because they want to put the application into your binary and not create a separate runtime that you ship together with your .py files. So what do we want to do in the future with the next releases? Of course, we want to add better documentation. The documentation is very, very limited at the moment. We want to improve on that. We want to make the configuration itself of Pyrun very flexible, ideally with the setup.py kind of approach. We want to add Windows support, if that's possible. And we want to have, well, already mentioned that setup.py, the configuration itself should be possible by not editing the config file, but instead just giving parameters to the setup.py and then have that take care of everything else. Right, so instead of questions, I think I should do a demo. Are there any questions so far? Oh, lots. Okay, so I'm going to hurry up. Just need to find the right window. This is going to be a bit difficult because I cannot see what I'm writing. Okay, so these are the precompiled packages that we have for Linux. So I'm just going to get one of those because compiling Pyrun would take too long now. So let's see. Take the 2.7 one. Let's say UCS4. We need this one. So now you have Pyrun installed. You can see 12 megabytes. We also ship with a debug version of Pyrun. But you don't need that if you're doing production work. Then we have, we have the standard lib directory. We have two directories in here. One is the lib dinload. That's the standard directory that Python uses for loading shared modules that come with Python. So as you can see, there are a couple of things in there, including the readline library and the under multiprocessing that we have not included. And then you have the include directory. Which has all the header files. We include all of these things in the download packages because if you want to compile extensions, then you need all this. If you just want to run Python scripts, then you can just remove everything and just use the bin Pyrun. So how does it look? You just start it up like this, comes up with a prompt, and from there on there's really nothing special anymore. I mean, it's just, you can just do stuff. You can have a look at the path, for example, and you can just import what am I doing here? Oops. See, you don't have readline support for some reason here. Yeah, not very spectacular. Anyway, so let's install, for example, let's install setup tools. Oops. There you go. You just run it like you would normally do with Python. So it's the standard setup.py install dance. And then, oops, then we want to use pip for installing stuff, so we can uninstall it again. And so you install pip, same thing. And now we'll have to see whether the network works here. And we're going to install a package that has C extensions. Eugenics MX Base comes with a few C extensions. So ideally it will now download Eugenics MX Base from the website and then start compiling it. And this step often takes a bit for some reason. Okay, so I'm going to ask questions while it's doing that. First question. Back there?
Hi. So you mentioned about Pyrun missing a few things like readline and like multiprocessing, things like that.
Yeah.
So forgive me if I missed something, but is it just a simple case of like getting pip and then installing multiprocessing? And also, if once you've got that installed, like how would multiprocess behave? Like, is the performance just the same as in normal Python, or is it any different?
Well, we tested multiprocessing using that extension under multiprocessing as own. It seems to work fine. So
it's just basically the same as in normal Python, yeah?
Yeah.
And is it just a pip install of that, like I said, or like
if
you just add that in with pip? Or?
No, you don't. Well, multiprocessing is a standard lib module, so you don't really need pip to install it.
Yeah, that's what I mean. So you're saying it's missing from Pyrun, so how would I just get it in?
It's the .py multiprocessing is included in Pyrun. It's just that the extension module for multiprocessing is not included in Pyrun. But as I've shown here, you have that in that lib directory as SO file, and if you install that SO file together with the binary, the Pyrun binary, then it does work.
Okay, that's great, thanks.
So sorry about that, but it doesn't appear to have an internet connection here. Some reason. Maybe if I unplug this one and then it'll just use the...
Yeah, question? I will bring the microphone. No?
Next question?
Next question?
Yeah,
okay.
Here.
Have you measured the differences in memory footprint between Pyrun and stock Python interpreter?
The memory requirements, well, we haven't actually looked at the memory requirements, to be honest, but the memory requirements should be very similar, except maybe for this one thing that it's possible to share the .py bytecode.
On the other hand, as far as I understand, the freezing mechanism, much of the standard library is preloaded, which can make also a difference.
I can show that. It's if you look at the sys modules, you'll see quite a few modules in there, and you always see from frozen. So those are all frozen and already loaded into the process. Another question?
Yeah.
So a couple of questions, I guess. First, you said that Python 3 is not supported. Are there significant technical reasons, or is it just a question of motivation and time? How long do you think it would take to
It's just a question of motivation and time.
Okay, there's no big...
We haven't, well, I know that there are quite a few changes in the way that Python 3 is set up, so I'm not really sure whether it would work or whether it would require extra patches to the freeze utility that comes with Python. Because the freeze utility it's very old. It's from the, I think, 1.2 days of Python. Or even earlier than that. So I'm not really sure whether it's still actively supported in Python. We had to patch freeze, for example, to get it working for our purposes here.
Okay, the next question was the Egenix license, how does that interoperate with commercial products? Is it just completely free, or is it...
Yeah, it's just a standard Python license, just has then the Egenix name on it, and that's it.
Right, okay.
Any more questions?
Did you try to get those patches for freeze upstream to the Python?
No, not yet.
Do you maybe consider this?
Yeah, sure.
Okay.
Why not? Well, I am a core developer, so I can just check them in myself, but I haven't done that yet, so... Forgot the question, yeah?
Next one. Yeah.
You said you were working on making it compatible for Windows. Is that like a thing which is almost done, kind of half completed, or not even started yet? And when could that be expected?
Well, let's put it this way. I know that freeze used to work for Windows, maybe 10 years ago. So there might be some issues.
Okay, we come back.
Okay, sorry. How flexible is the build process of Pyrun itself? As in, can you easily customize which modules get shipped? Can you add your own modules?
Yeah, you can. I can adjust because the pip install doesn't appear to work. So let's just go in there, and then what you do is you go into this Pyrun directory. This is just standard package stuff there. And Pyrun itself looks like this. It doesn't come with Python itself. It downloads Python when you start the make process. So what you, for example, if you want to remove more, that was wrong. If you want to remove modules, then you can see these setup files here. Let's take this one, for example. This is for C extensions. So if you don't want, for example, to have the under IO module in there because you don't need it in your whatever you're doing, then you can just comment out these things, or you can comment out other modules. For example, we included the BZ2 module in there, and we also included the zip module. We have included the under SSL module. So those obviously add dependencies on the binary. So if you want to make Pyrun even more flexible, you just remove those. Of course, then you cannot use the modules in your application, but that makes things easier. We've tried very hard to get SQLite in there, so this is basically just hand-edited stuff, and you can see up there are certain conditions in there that we had to use because we wanted to get it working on FreeBSD, and FreeBSD installs things a little differently. So a lot of these are just hand-edited stuff that we've configured like this, and you can remove them by just commenting them out, or you can add new things to those setup files. If you want to change the .py files, then you have to look at this file. This is the template that's being used for the startup. So you import the configuration there, and then you have command line stuff, which is not very interesting. Let's go down here. So at the very end, what happens is it replaces this $imports with all the modules that it finds in the standard library, and you can remove things from the build script that does this, that uses this template to actually build the Pyrun.py that's being used for freezing the application. If you want to add extra things, it's very easy. You just have to create these modules down here, Pyrun extras, which is currently empty. You just add an import to that, and it just includes whatever you put in there in the final binary. So that's very easy. Does that answer your question? Yeah?
Any more questions? No one? No? Okay, seems no question.
Okay.
Thanks everyone.
Forgot to mention it was released on Monday, so it's very fresh stuff. So.
Okay, thanks everyone. Now it's break for the lunch.